Lesson 7.2, and we're going to do a few examples to get you guys started on your assignment. All right, the first example says for each function f of x defined by the given set of ordered pairs, determine a restricted domain on f of x for an inverse function, f inverse of x, that contains the most possible ordered pairs. Then show the ordered pairs of the inverse function. All right, so the first thing we see is that for each function, all right, so it says this is a function, and if we look at this, we can see that all the x's are unique, which means it's a function. So we're starting with a function, and we want to find the inverse. To find the inverse, we have to switch the x's and y's. So let's go ahead and switch all the ordered pairs, and then we'll answer the question. All right, so the first one's going to be 30, -1, 10, 0, -2, 1, -6, 2, -2, 3, 10, 4, 30, 5, and 58, 6. All right, so let's read the question again. So for each function defined by the given set of ordered pairs, determine a restricted domain for f of x. Okay, so we're going to restrict this function for an inverse function that contains the most possible ordered pairs. Then show the ordered pairs of the inverse function. All right, so now if we look, we've got 30, 10, -2, -6, -2. We've got 2 with -2, so we have to get rid of one of those. We've got 2 with 10, and we've got 2 with 30, and then 58. All right, so the ones we have to look at are the ones that repeat. So we've got 30 twice, we've got 10 twice, and we've got -2 twice. All right, so it says restrict the domain of the original function to where we can contain the most possible ordered pairs. All right, so if we restrict the domain, if we get rid of the first 3 ordered pairs, then that means we're going to get rid of the first 3 inverse ordered pairs, and now it no longer repeats. So our inverse function would be this on the restricted domain. So our domain for our f of x function would be 2, 3, 4, 5, and 6. All right, determine the inverse of each function. All right, so this is just straightforward, find the inverse. All right, so to find the inverse, remember you just have to switch x and y and then solve for y. So the first thing we want to do is replace f of x with y. So y equals 5x squared. And again, this is just a restriction on the domain because this is a quadratic, and we know the inverse is going to be a square root, and we have to restrict the domain so that it's a function. All right, so once we replace this, then we switch the x and y. So we're going to have x equals 5y squared, and then we solve for y. So we're going to divide both sides by 5. So I've got x divided by 5 equals y squared. And then I'm going to take the square root of both sides. So I'm going to have f inverse of x equals the square root of x over 5. And we know this is just a positive square root because we limited this to x greater than or equal to 0. So this would be the inverse of f of x. Excuse me. All right, so next example. Again, replace this with y. We're going to have -6x cubed. Now we're going to switch the x and the y. So switch x and y. So we're going to have x equals -6y cubed. Now, where on this one we divided by 5 first, Okay, on this one it's in parentheses, so we have to take the cube root first. We have to get rid of those parentheses first in the power. So we're going to do cube root of x, and we're going to do cube root of all of this. So if you take the cube root of this, it cancels the cube power and leaves negative 6y. Now we're going to divide by negative 6. And this is going to be the inverse. So f inverse of x equals the cube root of x over negative 6. So the order in which you do the operations depends on whether you have those parentheses or not. All right, and there's no restriction on the domain here because a cubic function and a cube root function do not have limited domains. All right, the next example. So we've got f of x equals x squared minus 6. This is a quadratic again, so yes, the domain is restricted to all positive numbers. So let's start by replacing this with y. And then we're going to switch the x and the y, so we're going to have x equals y squared minus 6. We're going to add 6 to both sides. And we're going to take the square root of both sides. So f inverse of x equals the positive square root of x plus 6. So remember in the past when we took the square root, we did a plus or minus, but you don't have to when you've got a restriction on the domain. You're just looking at the positive side of that. All right, the next example, replace f of x with y. 2x cubed minus 8. All right, we're going to switch the x and y. Now we're going to solve. So when you solve, you're undoing the order of operations. So we're going to add 8 first. We're going to divide by 2 next. And then the last thing we're going to do is take the cube root. And because you're taking the cube root, all of this is on the left. You have to do the cube root of everything there. So it's going to be cube root of x plus 8 over 2 equals f inverse of x. And that's all for examples for lesson 7.2. If you have any questions, please let me know.